so numbers online, and we have all the team here, although you cannot see, they are sitting in front of me. So very important day for us today because we are announcing and launching the Zeta platform. So without further ado, let's get started and let me try to introduce what this platform is all about. Okay, so when you present a new technology or a solution, you should always start with the problem that you are trying to solve. And the problem that we are trying to solve is essentially avoiding people having to build a Frankenstein solution, and what I call the digital Frankenstein. So what is the digital Frankenstein that people are building today? Well, if you have a problem or a system that requires you to go from the microcontroller up to potentially a data center, like in the public or a private cloud, up to yesterday, right, you couldn't do it with a single technology. Up to yesterday, you had to use a collection of technology only to make data flow. And we were one of the company witnessing this because, as you are probably aware, we were involved in a smart city or building smart cities since 2008. And back then, some of the systems that we had to deal with were small sensor running perhaps on the roadside, then gateway running on lampposts, up to then going to a data center. And so there was already a very heterogeneous computational platform, from microcontroller to server-grade hardware, very heterogeneous network, because these small sensors were communicating through low-power networks with gateways that then eventually were communicating or had to communicate and bring data to the cloud. And back then, it was, again, a digital Frankenstein, like this pretty ugly picture, stitched together because there wasn't a single technology that was allowing us, again, to have data flow from the microcontroller up to the data center. And if it was only about data movement, I mean, this data at some point has to stop, has to rest somewhere, right? You want to store it on some databases, only to then recover it. But once again, the solutions were centralized, and that was creating a problem with respect to either the energy used to bring all the data there, or the energy used eventually to get the data out. And as soon as you have battery-powered device, energy becomes an important element of the equation. Not to forget that energy is an important resource and we want to limit its waste. But then we are forgetting another element, which is computation. Because if we move data around, or we store data, it's because we want to make computation. We want to get some clues out of this data. And then we get with yet a third technological access. And so it was really a digital Frankenstein. Several technologies and several protocols to go from the microcontroller to the data center, and then yet another technology stack to access data at rest, and yet another technology stack to deal with distributed computation. And everyone, I felt, was living in a Plato cave, right? Because this was the world that had been put in front of their eyes, the only world they knew, and the only things they could accept as reality. But I think at ZettaScale we couldn't, right? We thought there had to be a different way. That cannot be just the only way. And so sometimes people decide to get out of the cave, and then when they come back and they tell, hey, there is a different world that can be built out there, they look like crazy. And but then the few that believe, right, and see, they will eventually understand that indeed there is a different way. And this is a different way to address data movement, right? Because ideally we would want to have a single technology that is able to go from the microcontroller to the data center. And the reason why we have not had such a technology up to yesterday was because those problems weren't there 10 years ago, or 20 years ago, or 30 years ago. And if you remark, most of the problems that you're using today were at best designed 20 years, if not 30 years, if not 50 years ago. So it is just a consequence of an evolving world, technology evolving, right? That protocol that could deal with this problem space weren't there. The problem of data at rest. I mean, historically, the database and the communication domain had been segregated, right? There were people working on storage, people working on communication, and then eventually, you were putting the two things together. But nobody really given a systematic thought at how these two concepts, which are the two sides of a coin, right? It's always data. And why, if it's in movement versus it's at rest, I have to use two completely different technology stacks with completely different API, not integrated at all. Once again, people living in the plateau scale thought that was the only possible world, but we decided to step out and find a different way. Same things for computation, as I was mentioning before, right? Computation, you have to adopt another platform, right? Another technology stack, and it's a technology stack that, once again, sometimes is not even homogeneous from the microcontroller to the data center. And this is why today we're introducing the ZettaScale platform. Okay, ZettaScale is the first and only platform on the market that is able to unify compute, communication, and storage from the microcontroller up to the data center, let it be a private or a public data center. And it does it using a single protocol, which obviously integrates with many of the existing protocols. You might be using MQTT today, you might be using BDS, MQP, OPC UA, it doesn't really matter. Our infrastructure integrates very nicely with this protocol, as we've demonstrated in the past month. Before we had this holistic solution. It unifies computation, so you have a computational model that, again, it's applicable from the microcontroller up to the data center, and which is location transparent. This is very important because in large-scale distributed system, you want to be able to have load balancing, you want to be able to easily implement fault tolerance, and as soon as you have any technology that requires to be aware of the location of a service in order to invoke it, fault tolerance, load balancing become very complicated. And this is what most of the technology force you to go through today. Our technology, our platform is entirely data-centric, which means, or name-based, which means that you don't care about location. Now, we optimize, as I will demonstrate, and as we will demonstrate, the communication path, right, or the execution or the triggering of a computation or the query of a data store, depending on your location. And that is important if you want to build systems that scale, systems that perform, and systems that minimize communication overhead as well as energy. Okay. Last point is efficiency. Again, we have shown some of the performance that we can achieve. We've had several third-party demonstrating that our core protocols are above and beyond anything else that is on the market in terms of latency, in terms of throughput, and in terms of wire efficiency. And I would say, in general, energy efficiency. And again, we have written at least more than 10 articles in the past 6 months explaining why this is so. But let me show you this a little bit in action, and let me show you what you will be able to do today with the Zetta platform. So first of all, our platform is, or the cloud element of this platform is cloud agnostic. Okay? As we will demonstrate in 20 minutes or so, you will be able to deploy your infrastructure on your favorite cloud provider, and we will already show you today. You will be able to provision from our Zetta Pass your infrastructure from the data center down to potentially a device, or in any case, down to your premise. Let it be a car, let it be a robot, let it be a factory. And so this is what you see depicted here, because you see potentially clouds, or perhaps Amazon and Azure cloud, perhaps a 5G edge server, an edge server that might be owned by a factory. So this could be, as opposed to a car, an AMR. So you see, in general, it's a highly heterogeneous infrastructure, which is actually what you have in reality. And today, dealing with heterogeneity is very complicated. So we're trying to slash that complexity. And you see that communication goes transparently using the most efficient path, because in this area, if you have the ability of communicating peer-to-peer, then communication is done peer-to-peer. Communication then is routed through the network, and any information that potentially needs to be stored is transparently stored in any of the technology that we support as a potential backend. Here you have another example, again, of publication of data with a device that potentially has a duty cycle, so it's sleeping. And our infrastructure is able to cache this data as close as possible to the device so that when the device is ready to consume, it can consume this data at its pace, okay? And once the data will be consumed, the infrastructure will garbage collect this data. So very important use case because today we have more and more devices that are battery powered and or perhaps that are mobile. As a consequence, you cannot assume that they're always connected. I know we like to think that they're always connected, but just go on the Alps or drive through the Alps and you will see that that's not the case, right? Across US, you will realize that from time to time, even in those simple applications are not always connected. And other use cases relate to battery optimization. You would have duty cycle as a consequence, not always connected. Now, data was flowing in our system, it was stored somewhere, and that somewhere, again, can be controlled through our paths, because you can provision storage, and for every storage you can decide which set of data has to be kept. Obviously, you can control the level of replication, because that will impact both load balancing and fault tolerance. And now, suppose that I need to get some data, right, on this fleet of cars. So I issue a query, right? This is a distributed query, and our protocol will figure out how to respond this query depending on where I am on the network. So in this case, perhaps the most efficient way of resolving the query is querying directly the car. By the way, this is a use case that made our protocol recommended by the ITU for next generation ITS. We'll provide the link if you want to read the recommendation from the International Telecommunication Union. It's quite interesting because this is a case that is very close to a potential digital witness that is extremely important for autonomous driving. Now suppose, and obviously data, the query is triggered and the data is consolidated back. Now imagine I'm on the other side of the network and I issue exactly the same query. Perhaps based on how my storage are organized now, the optimal storage to answer my query is that one. So in this case, our protocol find out that that's the optimal route, that storage might be complete with respect to the query, and I get my data back. So once again, you see locality, which is super important, because we always answer a query in the optimal way with respect to your location in the network. And again, location is important because, or location awareness, that supports mobility, and that supports easily scalability in large-scale system, right? All of a sudden, it's very easy to distribute the data, to keep data close to the places where it's needed. And by the way, suppose that there was a hotspot at some point, and perhaps there were some queries that were being issued often from this portion of my system. I could, from the past, provision on the fly a storage here. That storage would be automatically aligned with the data that it's supposed to be holding, and then any query concerning the data space that it was holding that would be issued in this area of the system would be able to be answered by perhaps the storage that is here, as opposed to having to get up to the data center. But let's look at computation. Let's assume now that I want to get some computation for ADAS. Okay, so this car requires the edge infrastructure or the infrastructure somewhere to do some advanced, let's say, image detection that is not able to do on the car because it doesn't have the hardware. And by the way, there are use cases going forward in which the level of support to the drive and the level of, let's say, threat or danger recognition will be different whether you are driving perhaps downtown Paris or London or New York, because of the infrastructure that is around you and the capability for computing that you have on that infrastructure versus the capability that you have in your car. Another example could be your car battery level is low, so you won't use that to drive as opposed to power the data center that you have in the trunk, right? So in that case, you might decide that some of the function will be offloaded to the edge infrastructure if there is this edge infrastructure. And the ability of having location transparency in computation is also important. So notice here, I'm just asking to get some information that happens to be produced by a computation. And in this case, the closest computation that can answer that request is here. The computation will be automatically triggered, and I get the data. Now suppose this car moves, because indeed car move, and now I'm here. So I was moving, let's say, from Paris to Rome. Okay. Same request in this case will be routed perhaps to another computation. Again, locality is important. Locality gets you scalability, gets you fault tolerance, and allows you to have very dynamic architecture that again, you cannot build with traditional technologies. Okay, so at the core of the Zetta platform is the Zeno protocol, okay, because this is the protocol that ZettaScale we have designed that is able to go from the microcontroller up to the data center, the protocol that unifies data in motion, data at rest, and computation. So as you know, we have abstraction for web sub, we have abstraction for distributed query, and the same abstraction is used to represent distributed computation. So it's in a way deceivingly simple, and at the same time incredibly powerful. Okay, few abstractions, you can count them in the finger of one hand. We have publisher, subscriber, queryable. That's it. Okay, and with that three abstraction, we can do all of these things, and we can do them again from a microcontroller communicating over extremely tiny network up to the data center. We can run on top of a data link, so you can run Zen on a serial, you can run Zen on a CAN bus, on a Bluetooth, but it also performs incredibly on a 100 gigabit network. So once again, this is the protocol that is at our backbone. And it's an entire, obviously, ecosystem because we have the PaaS, right, which is what we'll be demonstrating in a moment, that allows you to provision the Zen infrastructure, so the router, and they will be routing, provision the connectors, because routers have a plugin system that is extensible. You can write your own plugin, for instance, for your bespoke protocol, or for a protocol that is not supported. We can also develop those for you, no problem at all. But you can provision connectors, and as we will see, connectors are connectors either to other protocols like DDS and QTT, or databases, for instance, RocksDB, or maybe you need a time series database like InfluxDB. We have a series of tools, and these tools are integrated. You want to be able to visualize your deployment, you want to be able to see statistics. And by the way, when we activate, suppose I have a robot or a fleet of robots that is communicating through our second DDS, or is using DDS inside the robot, I want to be able, right, to tap into that robot and to visualize the DDS data. Well, you will be able to do it from our bus using our tools, okay? And then obviously there is our router, which is the Zeno router, and the API. So today, the nice thing is that to program your system, you can use the Zeno API in any of the supported language, but you can use any of the API to build part of the system of the supported connectors. So all of a sudden, suppose you need to develop a portion of your system in DDS. Fine, use DDS and DDS API, but then another portion of the system on the microcontroller, or perhaps on some other enterprise grade, or on the cloud, can use Zen. You have already a portion of your system developed in MQTT, some portion DDS, some portion MQTT. Well, you can integrate all of these in our platform through our connector, and then use the power of Zeno going forward, right? So that's very, very powerful. And again, it was a recognition that the world is heterogeneous. There are multiple technologies that have been there. There is legacy, and that legacy, needs to be integrated and taken forward. So here are the connectors that we'll be releasing to begin with. So again, connectors to some of the key protocols and databases, both traditional databases as well as cloud stores like Amazon S3. But you also can use file system as a storage, and we support also memory storages. DDS is a special, it's not just a connector, it's a first-class citizen in our platform. As you know, we are the company that leads the development of Cyclone DDS, right? Cyclone DDS is the DDS implementation of the market. You're looking for DDS, think no further, that's what you should get. And again, obviously, as we do Cyclone DDS, the integration of DDS and Zeno is seamless and incredibly efficient. So we have just released a version of our plugin that, for instance, is zero code. So all of a sudden, you have a DDS application, for instance, powering a robot in ROS. It can zero communicate with Zeno and use Zeno for robot-to-robot communication, or perhaps to communicate to some edge infrastructure on the cloud. What does that mean? It means that essentially there is no runtime overhead when going from DDS to Zeno, which is super important. So the integration of these two technologies is very efficient. For Cyclone DDS, certification is coming up, and in fact, different dependencies of our platform will be certified, and certification will be available on Q1 2024. That's true for DDS, that's true for Zeno, and typically the portion that you would deploy on devices that need to be certified. But no, enough talking, right? Let's see something in action. So Gabriele, which is one of the key members of the PAS team. In fact, perhaps some of the guys of the PAS team can come close by. So we won't fit everyone on stage, but you guys can clap even stronger, right? Yeah. Okay. So they will be taking us. So hello, Gabriela. Hello, François.
Hello, I'm Nicolas.
Okay, so they will be taking us to a demo because in the end, without a code and without running code, it's just blah blah. So let's take a look at the real stuff. So let's go, guys.
If it works, it's on you.
Yeah. And as they set it up, just a moment, Gabriele.
Yes.
Real quickly, what will you be showing, or what will you be seeing? So as of today, by default, we deploy, let's say, our front end. So what you will be seeing as a UI and all the logic on Amazon. But as I said, we are cloud independent. So in the demo already today, although, let's say, our front end will be running what we want, we will be the part of the infrastructure on-prem. And on-prem, unfortunately, you cannot see here, very beautiful, very close to Lecce, in a close natural reserve. This place is called Leccesine, so it's southern part of it, brilliant place. Maybe next time you will be able to join here. So we will be deploying some infrastructure on premises, and the nice thing that you will see is that you don't need to be bothered with configuring anything, right? Because in general, if you were to use a third-party technology, then you have to configure security, you have to configure locator, lots of things to configure. That's annoying, right? Real innovation removes steps, and that's what we do. So whenever you create, you start creating infrastructure, we can automatically generate images that contains all the plugins that you need of your infrastructure. And then we will be displaying with some application that when running locally, obviously, will only communicate through the local infrastructure. If there is some remote subscriber, we'll go to the cloud. And in general, the advantage of our platform is that communication is limited and kept local, right, to the scope that where it happens. So if you were to use some cloud solution based on MQTT, all applications would have to communicate through the cloud. Once again, that's latency, that's a huge waste of energy, and very hard-coded topology, because that's today creating massive scalability problems to several companies, right? Decentralization is the way to make scalable system. The point is that so far decentralization was very hard to manage, but we've come to make it simpler. So let's go to the demo, and I will be, yeah.
It should be okay. Yes.
Okay. So as you see, this is the login page for our platform. So then let me just log in. So while you're looking, see, I don't have any project there, so I can, this is my project, I can see my account there. So now let me create a Zeno project. So let's call it live demo. I will not put a description, so let's put very.
Yeah, you put a comment here.
Yes. Yeah, with French keyboard, sorry, I'm not used to French keyboard, so the N is where the. Okay. So in this case, I said it's deployed on Linode. So the front end is running, as Angelo said, on AWS, but our platform will also be provided on Linode. And then let me select a name for this. Let's call it also like that. To avoid any mistake, I'll just copy paste it.
So we automatically generate.
Yes, we will automatically generate a domain name for you, so that when you need to connect your locator, will just be the ZettaScale platform. And we can go next. Here we have our wizard in which we can add connectors or storages. So connectors, for instance, can be an MQTT connector with all its configuration, and storages can be any kind of storage, which in the case of the cloud will be mostly time series and RocksDB, but you can also have in-memory or file system, as Angelo described. So without further ado, let's start our deployment. Yes, internet connectivity as usual. So let me just do it. Okay. So as you are seeing, is now starting deploying. So the deploying phase takes around 2 minutes because we have to provision all the cloud infrastructure, which includes VMs, includes virtual networking, includes object storages, and of course the Zeno router that we need to deploy and firewalls. And of course, as we are on the cloud, we need to be secure that the connectivity. So we need to be to encrypt the data that's going through. We also need to generate TLS certificates. So that's the part that usually takes most of the time because he has to verify that we are all the owner of the domain. So while he's doing so, he will deploy everything and it will take again around 2 minutes. Yes. So in the meanwhile, while it is deploying, let's have a look at a few code examples that we are going to deploy. Okay. I hope it's big enough. So what we are going to deploy, we are going to deploy one of our examples, so a publisher and subscriber. So if we do a look, for instance, at Zeno publisher example. So this is an example of Zeno, but then what matters is just these few lines in which we are. So this is all, of course, this is all argument parsing, and this is not really interesting. But opening a Zeno session is as easy as opening a session, passing a configuration. Then we can just declare a subscriber. In this case, we are just declare publisher, and then we are just sending out data. And you can see that once we declare publisher, publishing is just a matter of calling publisher.put with the given buffer, and the data will go through. Of course, and when you're done, we can just undeclare and close our session. This is an example of a subscriber. Let's take an example of a subscriber. So again, most of the code is parsing the arguments, but as you can see, we are again opening the session, one single line. We are declaring a subscriber. So first we are declaring a subscriber there with the key expression, so the topic name that we want to listen, the callback, and the reliability we want for this subscriber. In this case, the listen is this simple function that receives the data and prints out the payload and the key expression of the data that is being sent, and what kind of symbol it is. So if it's a get, if it's a put, or if it's a delete. And so that's once we declare the subscriber, we just wait there until we want to stop the process, and then you can just undeclare and close our session. Let's check the status of the provisioning. So it's still deploying. So most probably it's deploying the virtual machine, which is the part that usually takes most of the time. Again, together with the the TLS certificate generation.
Okay, so as we wait for that, I would like also, if we go back for a moment to the example, for instance, the publisher. Actually, as you see here, so Gabriele showed you the opening of the session here, and then the declaration of the publisher. Actually, the declaration of the publisher in Zeno is completely optional. So this application here actually could have been reduced to 2 lines, which is the opening of the session, and then the put on the session. In that case, providing key. And what you can do, as a shortcut. Declaring a publisher is something you need to do really if you want us to optimize certain things, right? When you have recurrent writes. Something also worth mentioning is that although in Zen we have this key expression, right, that used to represent or name your data, one of the things that we are able to do whenever you register a publisher, right, there is a well, you are telling us, look, I'm registering a publisher, so this is something I'm going to write often. So in that case, we will automatically encode your string with a small integer. And so whenever you will send data to a put, right, on the wire, we will only send usually a 7-bit integer to represent the key. If you don't declare a publisher, then in that case, right, we still do some encoding of your key expressions on your key, but that's done, based on the heuristics by our platform. So that's just for you to know. But we are done with the provisioning. So Gabriele, back to you.
So as we can see here, it's telling me, okay, your infrastructure is running. Okay, let's click on the name of it. And we can see that we have a single Xeno router that is deploying on the cloud. Now I want to use this router. So if I go there and to use my project, I can see the configuration that I need for a client, the configuration that I need for a peer, or if I want to connect a router that is on premises. Again, I can select connector or storages to this router, but without further ado, let's just ask him to generate a configuration. So I just clicked next. So now it's going to generate a configuration. It's giving me a link where to download this configuration. And it takes some time because you have to put this configuration on the bucket, retrieve it back, and create a secure link so that only you can download this configuration. So see, this download here my config. So what I will do, I will just click on this link, which is downloading a configuration for me. So in this tirelessly that we are going to open. So let's open the terminal. Let's open a new one. Make it a bit bigger. If I go to downloads and just decompress the file, we can see what there is inside. And no, it doesn't. That's because of my course. Yes, the French keyboard is it. Okay, that's usual permission problem of the terminal. Let's open the other terminal. Let's open this one. Download. Okay, we said mouse. So we want to decompress it. Okay. So it decompresses the file, so if we open it, okay, let's just open the configuration file. So change the directory we like. Okay.
Yeah.
Yes. Fine. I get me started by the French keyboard. Maybe it's a bit bigger actually. So okay, it's a minified JSON which contains the configuration, but as we can see there is an ID that is the Xeno router ID, where it's going to connect. So this is the name that we give to our deployment, and then where it's going to listen, and all configuration for multicast and everything else. So in this case we will have some multicast is enabled because it's a local deployment, it's a router, and so on and so on. And then we have configuration about permissions and plugin that in this case there is the HTTP plugin, but we didn't deploy any storage, but the storage manager plugin is still there. So now we need to start this router. So let me copy the file to my PC. Keyboards is the easiest one to use.
And something that we will also be releasing is a Zeta control that will help in the generation of examples in pre-configuring your laptop with the credentials for your application and various other elements. So that will be coming with general availability of the platform. So some of this step will further be automated. Yes.
My password. Nope. Yes, it's the French keyboard that I'm not used to.
Why you decided to do it on French keyboard?
It
was just to make it harder.
Yeah, to show that even if you are not familiar with the keyboard, you can still use it. Okay, fine. Let me download the configuration directly on my PC.
Yeah, so apparently he's making his life harder because he's using Azerty as opposed to the QWERTY that he was used to.
Yes.
So did someone change his keyboard overnight? He's using
I'm using Francois laptop.
Yeah.
Okay, so I edit there. Perfect. Download it. Okay. So add another terminal here, which was the one with everything. Okay. So in this terminal, I can see here, it's, I don't know if it's big enough. Let's make it a bit bigger. Let me see. Okay. So open it. So I'm in the download of my laptop. So creating new shortcuts. So that's part of the game. Tab, mouse.
Slow down.
Tab, mouse. X. Okay, so I decompose it. So let's get the config. And we have a Docker compose file. Why? Because we want to be able to deploy the router just setting a very simple command, which is the Docker compose start. So it's running, which means that if we go back to our platform and we go back to our network map, we see two routers. So we have a router that is on premises and a router that is on the cloud. If we try to zoom in a little bit, this link is blue link and this dot because it represents that is a TLS link. So then we are able to represent links also if they are based on different connectors. Okay, now we have chosen routers, but still no application. So let's deploy an application. So here we have our subscriber, our publisher. So let me just deploy it. So I want to deploy this I want to deploy this publisher as a local publisher. So I just need to start it. Z_pub .python. I want him to be a peer, so using peer-to-peer, and I want him to connect to my local router. So just put it here, TCP/ my local address, and the port, which is 7447. 7447. So it's opening a session. So now we have a publisher that is publishing. Let's see if it's true. Yes, we have a publisher connected to our local router. So this is our local router. This is the link. In this case, it's a TCP link. That's why it is yellow. And this icon represents the fact that it's a peer.
Color coding.
Color coding. So this peer, the peer is in white. I think if we deploy a client, that is what we are going to do right now. It will be a different with a different icon. So again, I'm in the examples directory. I have a subscriber that is a client. So let me just start it. So he already started. He's receiving the data, and you can see we started by giving the client parameter and setting the locator. And let's look for our client in our infrastructure. We can see there our client. So in this case, there is no data actually going through the cloud because all the data is locally because there are no subscribers that are interested in this data to the cloud. Yeah.
So this is, for instance, an example of what I was mentioning before. You were using MQTT. You could have not done this, right? Your broker would have been on the cloud. You'd be communicating off the cloud, paying obviously the energetic cost and the cloud bill. Here, you are not paying any cloud bill, right? Or very limited cloud bill, because for this communication that is local, no traffic is required. And as long as there are no subscriber or storage, right, there is nothing being sent over the cloud.
Okay, so now I would like to start something on the cloud. So I would like to subscribe to data actually coming from the cloud. So connectivity. Let me just refresh it because apparently our network here is not. Okay. So I want to have a client. So I can see here, this is the configuration that I should use for a client. But as I have something already prepared, what I'm interested in is just the locator because I want to connect again via TLS on the cloud. So I go there, I open my configuration, and I just paste my new locator, and then I need to start this client. So I want to start a subscriber, so I just do Python 3, and then I need to create my subscribe, which is z_sub.py, and I need to pass a configuration. So that -c the configuration. So in the session, is already receiving the data. So we can see that the same data is being received from this publisher that is local, 172, well, okay, 164 now, okay. So they are proceeding at the same pace, but this guy is receiving data from the cloud. How we know? Because if we go back to our network map, we see that now there is a new client connected to the cloud. So this means that now this publisher is publishing data to this router that is sending this data either to this client that is directly connected, but he understood, thanks to Zeno, that there is someone interested in this data towards the cloud, so he's sending this data towards this router that then is sending directly to the client that is connected to him.
Great. Okay, thank you very much, Gabriele, for the demo. And by the way, something else I wanted to point out is that in here, right, we make things with, we have a peer, a router, and a client, right? But topologies that are supported, you could have a bunch of peer communicating peer-to-peer, and then the router automatically routing data to a remote client. And by the way, we could even have a situation in which, suppose that you had some weird low-pan network here. Some peer could actually route information on behalf of clients, because that's a topology that we support, and eventually a router routing on behalf of peer toward the cloud. So the kind of flexibility and topology that we support, it's limited only by your, by your creativity, let's say. We have not, likewise, at some point you decide that you need a DDS connector or MQT connector, you can provision it as we've seen. And concerning the provisioning time, you have to understand that that time, I mean, you saw how fast it is to run a Docker container, right, through the compose. It was, I mean, a couple of seconds, maybe what, barely 1 second, let's say. But the time that it took, it's really all about registering the domain, generating certification, generating certificates, and making sure that all the security infrastructure is in place, plus all the coordination. A portion of that time, you only pay for it the first time, as a user, you build a project, right? Or you create an entity. That time won't be there for any other project. And you understand that in any case, even if it's the first time 2 minutes to deploy something, this is something you do very rarely, but all the rest of the activity, it's extremely fast. So thank you very much, by the way, for the demo. Next time, don't take a French keyboard.
Yes. Well, there was some issue with the projector.
So he can actually type very well, but on a QWERTY. So I just wanted to make his life so hard, like to pick an assertive. So again, thank you. Everything worked perfectly, so thanks very much. And I would like to inform you that we will be online again tomorrow with some more information announcement, in that case on our core technology and what's coming next. So thank you for joining us. Ciao from Lecesine in Italy. Bye.